just to summarize what we've been doing, okay, this whole unit is dealing with how to analyze data, and we talked about two types of data, categorical data and quantitative data. And we first talked about categorical data and how we can show it and analyze it, okay? We show it using two-way tables. We can also show it using bar graphs, and we analyze from there. For quantitative data, there's much more analysis involved because we can analyze four things. Do you remember what they are? The four main components of analyzing a distribution of quantitative data: shape, center, variability, outliers. Good. Okay. So we talked about shape in 1.3. And we talked about if something was roughly symmetrical or skewed to the right or skewed to the left, and if there was a single peak or a double peak. Now we're going to talk about center and variability together, and then we're going to finish by talking about outliers. Okay. For this lesson, we're going to use this example. Okay. We've got the salaries of 12 employees at some company given in thousands of dollars. So first we're going to talk about measures of center, and there's two types. One you're familiar with, okay, average, but we don't call it average in stats, we call it mean, okay? And another one that you may be familiar with, median. Those are the two main measures of center when we're analyzing quantitative data. So the mean of a distribution is simply the average. And to find the mean, this is the symbol we use to denote the mean, X bar. Okay? And it's the sum of all the data values divided by the number of data values. In fancy notation, statistical notation, it looks like this. And this you will get on a formula sheet. Although you really don't need a formula sheet for it, because I'm going to show you guys towards the end of the lesson how you can use a graphing calculator to find it. Actually, how you can use a graphing calculator to find all the information we're going to talk about. So you don't have to find each one separately. You just have to punch in all these numbers into your calculator, do a certain calculation, and out is going to pop all these measures, which is nice. This here, this symbol here, just means sum. It's the capital Greek letter sigma. So all it means is we're finding the sum of all the data values divided by how many there are. Okay. So in this example, to find the sum of all the data values, we would have to add all these numbers up and divide by 12. So I'm going to go 39 plus 34 plus, just to save some time, dot, 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 plus 29 plus 67 divided by 12, because that's how many there are. Okay. And when you do that calculation, oh, I don't have my, you're going to get 601 divided by 12, which equals 50.1. But units are really important when you're calculating measures of center and variability. So this is not a completed answer. What would you say the average is? If it's 50.1, what does that mean? 50.1, so 50,100. So you would have to write it 50,100. Units are important. So that's mean. Okay. What's median? Well, median basically represents the center of a distribution. So to find the median, we need all the numbers in ascending order, smallest to largest. Actually, it would work largest to smallest too, but normally we just do smallest to largest. Then we have to find the middle number of the data and see what value that is. Okay. If the number of data values is odd, there's going to be one number in the middle. So for example, if I said you had 11 data values, doesn't that mean you're going to have one in the middle, 5 below, and 5 high, 5 above to have 11? Okay. So there's one middle number when it's an odd number of data values. If there's an even number, there's 2. Okay. And how do you find those 2? Well, basically what you do, divide this by 2, that will get you one of the middle numbers, and then add 1 to get the other middle numbers, the other middle number. So here, the middle numbers, I would do 12 divided by 2, the 6th one, and the 7th. So 12 divided by 2 is the 6th one and the 7th. So I count up 1, 2, 3, 4, 5, 6, 7. Here's these 2. And it makes sense because there's 2 in the middle, 5 below, 5 above. There has to be the same number below and above. And then what you do, if there's 2 numbers in the middle, you find the average of them to get the median. Okay? So find average. So it'd be 34 plus 35 divided by 2, which gives us 34.5, which converts in the context of the problem 34,500. Again, don't forget units. There's no symbol for median. We just use median or MET. Okay. So remember, these are measures of center. We're talking about whereabouts is the center of a set of data. Well, if we look at these previous 2 that we just did, we got pretty different numbers. Like for the mean, we got 50,100. And yet for the median, we only got 34,500. Those seem to be very different from each other. Any idea what might cause, like, which one is actually represents the middle of the middle of a distribution, or sorry, the center of a distribution better?
I would say median because you have a really big number of this small number.
Exactly, and we're going to talk about that towards the end of this lesson. That's called resistance. If there are, like, imagine, okay, 5 students wrote a test. 4 got 100, 1 got 0. Well, the average would be 400 divided by 5. The average would be 80. And yet 4 of those students got well above the average of 80, 4 out of 5. That 0 really dragged the average down. Wouldn't it make sense that, well, the typical mark, the measure of center, is really close to 100. We just had one outlier, okay? So yes, we would say that the mean is not resistant. That means if there's really high values or really low values, it can really pull the mean up or down. Whereas the median, it won't do that too. So we say the median's resistant. But we'll wrap that up towards the end. So you can find or approximate mean and median in graphs. Okay, you could do it on a dot plot. You could do it on a stem plot. You could do it in a histogram. Remember, we're talking about quantitative data, so we're not talking about bar graphs. So here we have ACT. Is everybody familiar with the ACT? It's just a special type of test that you write for entry into US colleges and universities, along with the SAT is another major one. So here we have 55 ACT scores. We want to approximate the median. Well, how would we do that? Yes, but this is even more important. Because remember, median is middle number, right? Which value, not the specific value, but which position number will be the middle value in 55 values? How do we find that again? So 55 divided 2 gives us 27.5, and then we bump it up 1. So it's the 28th position will be the middle number in the data. And yes, now you can use the frequency. So we've got to start from the bottom and find which bar is the 20 or the 28 data value in. Well, here there's 2, right? 3 more is 5. 5 more is 10. 7 more is 17. 9 more is 26. So 26 of the values are in these first 5 bars. This 28 must be in this one somewhere. So what I could say is the median is between 24 and 27. Okay? Because the 28th position will be in that bar. So the median, I don't know exactly what it is, because remember, histograms don't tell me individual data values. It's between 24 and 27. Like I said, you could do that on dot plots and stem plots too. You could find the median. All you do, remember, dot plots are always ordered from lowest to highest. Stem plots are always ordered from lowest to highest. So you just count until you find the position of the median value. So that's center. Variability. 3 types. Okay. First of all, and we talked about this before, is the range. The range is simply the difference between the maximum and minimum. So the range, we just take whatever the maximum value is in the data, subtract the minimum value, and that's our range. So in this example, the maximum is 185, the minimum is 29, and when I subtract those two, and remember units, I get 156, which converts to 156,000. And again, Remember units. You need units for measures of center and variability. Okay. It's not a great measure. It gives you a ballpark idea of how spread out the data is. But it's, I mean, again, it's not very resistant. Like if you have a really high value, that's going to make the range a lot bigger than maybe the spread actually is. Okay? Or if you have a really low value, it's going to do the same thing. So what we want to do is look at a couple other type of measures. Yeah. This one? Yes.
It's not extremely accurate. Is that why we say it's in between the two numbers?
Yes. Like I don't know. All I know is that it's somewhere between 24 and 27. It could be 25. It could be 26. I don't know. I only know that there's 9 numbers between 24 and 27. I don't know what those numbers are. Okay, so that's why I can only ballpark it in a histogram. Whereas a stem plot and a dot plot, you could find them exactly because we show each individual data value in those.
So that's why the previous one was more.
Right, yes. Good. Okay, the next one is called the standard deviation. And this measures, these are 2 really important words. The typical distance of the values in a distribution from the mean. So the standard deviation goes with the mean. In order to calculate the standard deviation, you need to know the mean. So this, like I said, you definitely want to because that's the phrase you use when you interpret the standard deviation. Like whatever number you get for the standard deviation, you would say the typical distance of the values from the distribution is whatever the standard deviation number is from the mean. Okay. The formula, and again, this is a formula you're going to get, but it will automatically calculate it for you on a graphing calculator. Okay, but I'm still going to show you the formula. So we use a little s of x. And what we're going to do is we're going to find the typical distance, each value from the mean. So we're going to take each value and we're going to subtract it by the mean, which we're going to have to calculate. And typical means average. Well, in order to get positive numbers, because we want the standard deviation to be a positive number, I'll explain this in a second. We're going to square it. And we're going to divide by the number of numbers, subtract 1. There's a reason for that subtract 1, but it kind of goes beyond this course. So you don't really have to worry about it because you're going to get the formula anyway. And then once we have that number, we take the square root. Sorry, I should add the sum of all these. Should have put that in there. So this is on your formula sheet. So just to go through this formula. Okay. Why do we subtract each data value from the mean? Why do we do this? Okay. Well, because sure I get this right. It shows how spread out each data value is from the center, which is really what standard deviation means. And when I say the center in this case, I mean the mean. Okay. But if I find all those, like let's say in those 12 numbers, the 12 salaries, I know that the average, the mean is 50,100. Okay. So if I take each of the data values in the table and subtract 50,100, some of them are going to be positive values, some of them are going to be negative. Because the lower numbers, like what's the smallest one? 39,000. If I found the spread from that, I'd do 39,000 minus 50,100, I'd get a negative number. If I averaged all those negative numbers and positive numbers out, I'd get 0, which is kind of useless. That means the standard deviation would always be 0, and that just doesn't make any sense. Which is why I square it. Okay? Because squaring makes everything positive. Okay? So makes all the differences positive. This way, the negatives don't cancel the positives to 0. And then why do I add all those values up and divide it by n minus 1? Because I'm finding the typical distance, which really means the same as average. Okay? And remember, we're doing almost the same thing here. With average, we divide by how many numbers there are. With standard deviation, we divide by how many numbers there are minus 1. The only reason we do minus 1 is it's been shown that it gives us a more accurate measure of the standard deviation. That's all you really need to know. Okay. So similar to the mean, we're averaging or finding the typical value all the values in the data set. And why do we square root at the end? To undo that square that we did in the formula. To undo the square we did earlier. Okay. So if we find this, excuse me, the standard deviation of the example we've been working on in this lesson, okay, we want to state it, calculate it, and we want to interpret You will often see this. Don't miss that in a question. So your number is going to have to be followed up with an explanation. So remember the formula. We're going to take the square root, and it's a long calculation, right? Because we're going to have to take each of the 12 salaries, starting with the lowest, subtract the mean, and square it. And then we're going to have to do the next lowest. Sorry, that's 29, isn't it? Oh, no, 39. It was 39. It wasn't in order. 39 is right. Plus the next one minus the mean squared. Plus the next one, plus the next one, plus the next one, all the way to the end one of 67 minus 51, 50.1 squared. And then we're going to have to divide all that by 12 minus 1. And then we're going to have to take the square root of that answer. That's a lot of work. Fortunately, you don't have to do all that. Okay, but I'm just showing you how we would go about doing it manually. And if you did all this on your calculator, you would end up with 43.61. And remember, we got to go to units, and it's a salary in thousands. So it's $43,610. So what does that mean? That means each salary typically varies. It's probably better to use than typical distance. Typically varies $43,610 from the mean of $50,100. That is the interpretation. Notice I'm using words from the problem, not just saying the standard deviation is 43,610. Okay. Any questions so far? Okay, let's look at the last one. The last one is something called the interquartile range. You can split, what do you think the word quartile means? Quart. Something to do with 4. Okay? Quartiles is when you split the data up into fourths. First quarter, second quarter, third quarter, fourth quarter. Or the lowest 25%, then the next 25%, then the next 25%, then the highest 25%. Okay? The first quartile will be the median of the data values to the left of the original median. The third quartile will be the median of the values that are to the right of the original median. Okay. The second quartile is the median itself because it splits the data into approximately 50 above and 50 below. Okay. The interquartile range measures the variability. I can't even remember what I had here. Oh yeah, middle. Measures the variability of the middle half of the data. So it's the distance from the first quartile to the third quartile. Notice that in order to calculate the interquartile range, or we call it IQR, we work with median. Okay? Standard deviation goes with mean, interquartile range goes with median. So how do we do this? Okay, well, here's the original data. Remember, the original median we found was here. $34.5. Okay, that's the original median, which represents the second quartile, Q2. Then what we do is we take half the data above, including the upper half of the second middle number, half the data below, and find the medians of those ones. So looking at the lower half, is the median going to be one of these numbers, or is it going to be the average of two of them? Average of two of them, because there's 6 numbers, which means 6 divide 2, the third and the fourth. And I take the average of those two. So average 34. That's Q1. And then we do the same thing above the original median. There's 2 numbers above, the values 39 and 43. So 39 plus 43 divided by 2 gives us 41. That's Q3. So quartile splits the data into fourths. Bottom 25%, next 25%, next 25%, highest 25%. So now the only thing left to do is to find the IQR. We just take the value of Q3 minus Q1, which is 41 minus 34, which is 7. Which converts to $7,000. Again, units. How are we doing with graphing calculators? How many have them with you right now? 1, 2, 3. How many would have them tomorrow? But you guys aren't here. Okay. Well, somehow you're going to have to pair up with somebody. Okay. Because I want to show you how we find all these values using a graphing calculator. Okay. So there's 10 of you and 3 graphing calculators. Oh, you got one. Good, good, good. Everybody okay? You got yours? Kaylin, you got yours? Nice. No, I'm not surprised. I'm not lying. I'm not surprised. Okay. You're going to sit with the, you guys don't have one? Neither of you have one? So, Katana, you can go with Alex and Nira. Emma, you can go with one of these 2 groups. Okay, first thing we got to do, because it helps us enter data values, is we got to make sure the stats wizard is turned on. Okay? So to do this, you got to press, that's wrong. I've already got it wrong. It's not stat. I'm sure it's not stat. Yeah, I'm wrong. So make this correction, please. This should be, press mode. Mode.
I'm pressing mode.
Okay? And then scroll down using the arrows until you see Stats Wizard. Stats Wizard. And it should be on. If it's not on, oh, you don't have it on that calculator. Okay, so you don't need, well, you just don't need to worry about, you're going to have to, I'll show you. You good? Good? Because you don't, oh yes, because it's the old one. Yeah, you won't have it. Don't worry about it if you have the old one. It's just that if you have the old, if you have the newer one, it tells you specifically what data values to enter. If you have the old one, you have to remember the order to enter them in. So it's a little bit more difficult if you have the old one, is what I'm saying. But for this, you don't have to worry. For this, it's the same for both calculators. Okay, so second mode to get out of that, and you should have a blank screen. So what we want to do is we want to find all the information of the 12 salaries, so we're going to enter them all. Here's how you enter. Press Stat, and it should be highlighted Edit, and number 1, press Enter. You're going to see 3 columns. You got 5? Okay, so you got more. That's okay. We're only going to use the first one anyway. Everybody okay? Stats. Enter. There you go. Okay, so you should have the first box under L1 highlighted. Okay, let's start entering the data values from the beginning. So what you're going to do is you're going to go 39, enter, and it's going to take you to the next one to enter. 34, enter. 34, enter, and so on. No, yeah, 234s. I thought you said 234.
I'm so confused.
Okay, just a second.
Why did we skip?
No, we're not skipping.
Well, then what?
It's from the original table. It's from the original table, which is not ordered. You guys good now?
Yes.
Okay.
We just sound so judgmental.
I'm not sounding judgmental. Oh my God. We're good? Entered? Okay. Now, you guys entered?
No, I was slow.
What's that? Oh, you need to get rid of that. So highlight it. Delete.
Delete
DEL.
one.
DEL. There you go. Yeah, otherwise it may mess things up. Okay. So if you have all those entered, you're going to go back to Stat. Press Stat. But this time, instead of Edit, you're going to scroll over using the right arrow to Calculate. The right arrow. The arrows are to the upper right. And number 1, one variable stat should be highlighted. Just follow along. Enter. The list should say L1. The frequency list should say nothing. You don't want the frequency list to say anything, otherwise it's going to mess it up. Scroll down to calculate. Okay, I'll show you in a second. Enter. Okay, you're on the right screen. You just have to hit enter. Showed you all the. Okay. Got it? Yep. Got it? Hey.
No.
Oh my God. Okay, so stat.
That's what
Now
I.
you go right arrow, calculate, one variable stats.
Oh my God, am I supposed to?
Hit enter. Yes, you're going to have to remember. There's your list. There's your list of measures. Okay, so here's all the measures. Didn't we calculate the mean to be 50,100? The very top, X bar says 50.8. Go down to S of X, that's the standard deviation. N is the number of data values, 12. Use the down arrow key, and you can see all the minimum value, Q1, the median, Q3, and the max. All of that is listed for you, so you don't have to use any of the formulas or calculations. All you have to know is how to enter the list, okay, and how to go to calculate to get this screen. Don't worry, we're going to do it a few times. It's not like we're doing one and done, okay? Okay, just to wrap up, and I've talked about this already. Yes. So we talked about this before. The median is resistant to or not seriously affected by skew and outliers. What that means, skew and outliers, extremely high values or extremely low values. Okay? The mean is not resistant. If there's a really high value or high values, it's going to pull the mean up bigger than the median. If there are really low values, it's going to pull the mean below the median. Because the interquartile goes, the interquartile range goes with median, it's also resistant. However, the range and standard deviation, well, the standard deviation goes with the mean, and since the mean is not resistant, the standard deviation isn't going to be resistant either. And going back to our original example, and I've taken all the salaries and put them in ascending order, okay? We've got that really high salary of 185,000, okay? That's going to drag up the mean because its high value is given more weight in the calculation. Whereas in the median, the position matters more than the values or the weight. The position matters more than the weight. So if you think about it, like here, the mean is 50,100, the median is 34,500. If this was even a higher value, it would change the mean, wouldn't it? But if it was, it wouldn't change the median. The median would still be between 34 and 35. It doesn't matter what this is. It could be like 2 billion. That's going to really bring up the average, the mean, but it's going to do nothing to the median. It's still going to keep it the same because the position doesn't affect, or sorry, the position, okay, matters more than the weight. It matters more than the matters. Hello. Got a little excited there, I guess. Matters more than the weight. So it's not given as large a weight as it is with the median. And that's the same kind of reasoning for the IQR. Okay.
Just hang on.
Well, so you don't